4G, the small intestine. In addition to the pancreatic juices and the liver bile, the cells of the small intestine itself produces its own digestive juices, approximately 3 liters per day. Most of it is secreted by the duodenum, but is also secreted by sections further down called the jejunum and ileum. These enzymes include the disaccharides like maltase, sucrase, and lactase, peptidase that will hydrolyze dipeptides into amino acids, and nucleosidases, which release nucleotides. As the chyme moves through the small intestine via the peristaltic contractions, the small intestine will begin to absorb the nutrient monomers so that they can be transported, mainly by the blood, to all the cells of the body. The lining of the small intestine has finger-like projectiles about 1/2 centimeter to 1 centimeter tall, called intestinal villi, which increases the surface area of the intestine, allowing for maximum contact with the passing chyme. In turn, these villi are covered with tiny hair-like structures called intestinal microvilli. Here is a cross-section of them. Each microvilli has its own blood capillary network to actively and passively absorb nutrients into the blood, such as amino acids, nucleotides, and monosaccharides. An obvious omission is the fats. Fats are often in a form that is too large to enter the blood, so it must find its way into the blood using a different pathway, and that is the lymphatic system. Each microvilli has its own blood capillary network. It also has its own lymph capillary network, or lacteal. The walls of the lacteals are porous enough to allow for fats to enter freely through diffusion. The lacteals join to create larger lymph vessels and lymph nodes. Here you can see the larger blood vessels in red coming from the intestines, as well as the lymph vessels and lymph nodes in white. This diagram shows how extensive the lymph system is at the small intestine. The fat will travel with the lymph, and will eventually be deposited into the bloodstream where the lymphatic vessels join the subclavian vein near the shoulders. The blood then travels to the heart via the vena cava blood vessel. The fats are now able to travel via the blood to all the cells of the body.